Hi, welcome to everybody. My name is Pierre. I'm part of the R&D of Variscite software team. And today I will explain to you how to use the QML and what is the QML, so that we can reach a kind of QML demo that can be useful for your own projects. This will be the agenda. We will briefly talk about the Qt Quick, what is and how it's composed. We will go through the basic concepts of the object, like rectangles. We will talk about the anchors. We will talk about components. We will try to design a card dashboard, and we will go through the graphical elements that compose the card dashboard, and we will specifically talk about the canvas object of the QML. First of all, let me introduce Variscite. Variscite is the first one ARM-based SOM vendor in the world. We are currently selling over 1 million units per year. We are on the market since 17 years ago, and we have more than 5,000 customers worldwide. Our portfolio is mainly based on ARM, and we provide both extensive longevity and a dedicated compliance policy for each of our SOM. We are the only NXP Platinum partner nowadays, and in this partnership, we are able to provide you the whole IMX family product line. We have internal production lines that can allow us to produce cost-optimized SOMs to our customer. We can provide ISO and medical ISO certification, and we do also provide customer support and long-term longevity through an ecosystem of partners to allow the customer to reach a complete end-to-end solution. Let's give a quick view to our SOM portfolio. We mainly have two families. The families are pin-to-pin. Each family provides pin-to-pin compatibility between all of the SOM. We do have the wall, as I said, the IMX8 family, 8M Plus, 8M, 8M Mini, 8M Nano, the Varsom MX8X, and the Varsom MX8 that feature the IMX8 Quad Max and Quad Plus. Beside this, we also have the Varsom MX6, Varsom MX Solo Dual based on MX6, and the Varsom 6UL that is based on NXP MX6UL, ULL, and ULZ. All of these SOMs can be tested on a single board, that is the Symfony board, and you can switch from one SOM to the other simply switching the DSP, but still using the same hardware. Similarly, we have the Dart family that currently include the 8M Plus, the 8, and the 8M Mini. Now let's start with the presentation of the QML, specifically from Qt Quick. What is Qt Quick? Qt Quick is a set of instruments allowing the customer, actually the developers, to deploy, to quickly deploy user interface, let's say modern and dynamic, like the ones that you can see, for example, in an Android phone. So you have a fluid transition, nice to see, effects that are nowadays quite common. The main components of Qt Quick is the QML, that is a declarative language describing the user interface, and the graphical elements that can be used to, let's say, compose the user interface. Beside the QML, you have a C++ API, set of API, allowing to interface the backend, I mean the hardware, the real hardware. So you can integrate your kernel communication with the user interface. All of this run in a runtime, a rendering engine that is in charge to parse the QML and also manage the interaction with the hardware through the C++ API. Nowadays, this is a de facto standard in the embedded world, and mainly this is a cross-platform solution. When I say cross-platform, I mean that a developer is not supposed to know the hardware is working on. Specifically from the graphical, for the graphical aspect, you don't need to deal with the backend. You may use the frame buffer, you may use the X11 backend, you can use Wayland, you can use Android, Windows, doesn't matter. This is not a problem for the developer. The developer has a standard interface that describes the graphic, and this is what this is the main focal point of QtQuick. And also, QtQuick allows to quickly deploy user interface because of the simplicity of the language. Let's try to understand better how it works. As I said, there is a runtime engine that parts the QML and also take care of the C++ APIs that interface the hardware. This is a kind of shell, a sandbox that allows to manage both the graphical part and the hardware integration part. Let's start now talking about the objects that we will refer during this webinar. The first object is the rectangle. We can consider it the more simpler object that QML provides. So whenever you want to describe a rectangle, you just use a specific syntax for the rectangle, and you provide dedicated properties for this object. Maybe the color, the width, the height, and whatever. Keep in mind that QML describe your graphical aspects of your application. So just in this, just to satisfy this requirement, the graphical description may provide object within other objects. In this case, we are showing a rectangle, a red rectangle within a white rectangle. This is a simple example, just to let you understand how the syntax of QML work. Let's try to deeply understand this syntax. We have an import block where you can somehow include the libraries that you will use. And beside the library, you are also supposed to provide the library version. Just consider that libraries are provide backward compatibility. So whenever you say that you're going to use QtQuick 2.9, all of the following version of QtQuick will support your code. The same for the QtQuick.window library. Here we are saying that we will use 2.2, so all of the following version, 2.3, 2.5, whatever, will be compatible with this. Then we have the QML objects. We can see here a few rectangles encapsulated one within the other. And this will describe the layout from a hierarchical perspective. I mean, as you can see on the bottom right, whenever you describe these objects, you can encapsulate one within the other with your own logic, whatever you need. And this will allow you to also reference specific properties of the various objects. Let's start now understanding also the philosophy. Just remind that here we are not providing drawing commands. We are just describing the graphic. The QML is something that the runtime engine, at runtime, every time that an event causes a change in the layout, the QML is parsed again and refreshed. This will allow you to have a constantly updated interface. So the layout is written on demand, maybe because an event coming from a keyboard or from the mouse, or because the window has been stretched by the user or whatever. Keep in mind that every object has always a parent, because you can encapsulate more objects one within the other. But within a single QML file, you always have only one root object. The root object is the only one, being the main one, that has no parent. And as you can see, one of the first property here is the ID. Let's talk about the ID because it's very important. The ID is the unique identifier of a specific QML object within a QML file. Generally speaking, the main object may always be referred as the root. But beyond this, you can assign your own preferred name to the ID, as long as you are compliant with two main rules. You cannot start with capital letter. You may start with a lowercase letter, or alternatively, you can start with the underscore. In this case, you can see that the lower rectangle has an ID underscore myrect. The underscore is safe for the syntax of the ID. So just as a reminder, the ID must be unique within the QML file, and all of the objects may refer the properties, the ID of the parents. Not only because of this, the properties of each object may be referenced with specific types. I mean, they can be integer, boolean, real, string. The properties controls the behavior of the object, and they can be used to reference the object between each other. For example, in this example, the lower rectangle is designing its width and its height as half of the width and height of the main object. This will also cause that in case of redrawing, because of resizing or whatever, the red rectangle will be redrawn, keeping the aspect ratio. And this is one of the features of the QML. So whenever a property is changed for whatever reason, because you stretched or whatever, the whole graphic is rendered again, maintaining the properties aligned to the syntax that we are using. This approach of linking the property one each other is called property bindings. When we use the property bindings, we always need to declare to reference a previously declared ID, or alternatively, we can refer simply the parent. In this case, we declare that the main rectangle is a rect0, and we used it for the definition of the height, but the definition of the red one. But the definition of the width of the red one is actually the same, because we are referring to the parent. In this specific condition, rect0 and the parent are the same object. Okay, now let's go on and let's try to understand what are the anchors. In order to keep the alignment between objects, or the relative position between objects, in QML, you can use the anchors. The anchors are elements that control the positioning of a specific object referring to a different object. In the upper left case, we have two objects, A and B, that are one beside the other. The description of the item B, the object B, is that the left side of the object B is anchored to the right side of the anchor of the object A. This is the way we keep this always real whenever we render the QML in case of stretching or updates or whatever. This is one of the cases. We can also center one object with respect to the other. For example, in the lower left case, we have that the object small, that is small, is centered within the object big. These are two specific cases, but the anchor capability are much more higher. You can link to the left, to the right, to the top, to the bottom, to the center, vertical, horizontal. We have several options, and this is very useful whenever you need to link the object to one each other. But till now, we are still talking about simple objects. In a real case, always happen that you need something much more complex. To do this, you can group one or more than one simple object, doing something that you may able to reuse somewhere. This feature is called the component in QML, and the main object is reusing the QML code in different contexts. How this is achieved? Basically, you can declare a dedicated QML file describing a set of objects referenced one to each other to obtain something that is your target, then reuse this component as one of the base objects that we described, like the rectangle. Let's see a specific case. This case comes from the previous webinar we held, and you can find the complete code in our website. You will see the link at the end of the presentation. But one of the demo that we presented the last time was the QML button, the QML GPIO, sorry. In that demo, we shown a LED button QML that is a component, I mean a specific file describing a rectangle with an image, some text, and whatever. And in the main file, because the main file is the one that will collect all of the instruction, we referenced the LED button that, as I said, is a component, so has a specific QML file dedicated to its description. And we updated some of the properties of this object as it was a standard object of the QML. The syntax is basically similar to the one of the rectangle, but you can see that we added some specific cases like the label of the text, and we anchored this to specific left and right margin, the two images. As I said, the full code of this part is available in our GitHub. Let's go deeper in this code for a while. Here we used a very important capability that is the alias. What does this mean? Basically, whenever you want to access from externally a property of an object, usually you just refer the property object. But when this is a component, the syntax only allows you to access the components, the properties of the main object. In this case, the rectangle with the root. But in our case, as you can see here, we would like to change the label of the text for the button. In this case, we referenced in the main rectangle an alias named btn_label_text as button label.txt. Button label is the ID of the text part. .txt is a property that is being used to draw the text. This is how components work and how properties works. Now, let's try to understand how to design the car dashboard that we were talking about. First of all, we need a graphical design. This design may come from a graphical designer that may be completely unaware of what QML is. You can ask someone that is able to do this and identify the requirements from a graphical perspective only. Once this is done, we need to identify the graphical elements that compose our interface. So let's, going back to the initial image, we can identify a kind of background that we can see in the upper left side, the speedometer, a logo, the prindle, that is the gear view, basically, the warning lights, and in this specific case, we also had an external speedometer border that has been used to highlight the speed with an arc. So these are basically images that you need to identify in order to compose your final image, your final graphical GUI. This is not enough, however, because if we look at the image, we can see that there are parts of the GUI that are supposed to change. So we expect that the speedometer will render the speed, the kilometers done, the fuel and the oil vertical bar are supposed to change along the time to report the real status of the levels, and also the icons may provide warning or whatever. And not only the bottom bar, as you can see here, is supposed to render the date and the time and should be updated. These are not images. These are part of the application that are supposed to somehow update. Let's try to compose now what are the QML components we've seen before the images. Now let's try to understand the components. For the components, we have the bottom bar that need to render the text for the date and for the time. We need a vertical bar that is composed by two rectangles and a text providing the level information. We have the speedometer that should provide the actual speed and the actual kilometer done till now. The grid icons are supposed to change their status along the path. And also we have a progress circle that is supposed to render constantly the real speed. In our design, we assumed that the speed can range between 0 and 200. And this is the full, the yellow arc that you can see here is the full range that you can cover with the progress circle. Now let's try to understand how these blocks, these components have been designed from a QML perspective. Let's start from the bottom bar. The bottom bar, you can see it in the top side, have the two texts that need to be rendered. So let's go here and let's try to identify. We have the property, the strings that define the time and the date. We provided them some defaults, and we also declared the text that are supposed to render this part. And we also indicated the colors, the anchors capability, the font, and whatever. So this is the declaration of the bottom bar, and is a dedicated component. So it's a QML file, dedicated QML file. As component, this will be referenced within the main QML file that we call the central dashboard as a standard object. So bottom bar, and you can see it on the left, on the right, sorry, and all of the properties that you can go through for the various settings. This is for the, as I said, for the bottom bar. We also have the speedometer. That is a combination of text and rectangle and other text. Let's go back for a while to see the speedometer how it was designed. So we can see the text for the actual speed, the unit for the speed. We have a rounded rectangle that is used to encapsulate the kilometers done, and once again the unit kilometer. Here we can see the two texts for the speed and for the unit, kilometer per hour. And we can see the rectangle and a rounded rectangle with radius 10 that describe the gray part of the rectangle. This is only part of the code, as you may understand, because it's too long. The whole code is still available in our GitHub. Once again, this is a dedicated QML file describing the object, and the object is once again referenced, the standard object, a library object, let's say, within the main file that is our central dashboard. Now, as an addition, let's try to understand how we can draw an arc. This is not an image. We need to describe the speed with a yellow arc that is changing according to the real speed. This is achieved in QML using the canvas object. The canvas object is something that allows you to draw several things. You can draw lines, you can draw arcs, you can draw several things. One of the capability, as I said, is to draw arcs. And there is a dedicated API, as you can call arc, where you provide the center, X and Y, the radius, the start angle, and the end angle. And you can also decide if clockwise or not. Just remind that unless rotation, the angle starts always on the right. And when you provide the start angle, you are supposed to use this as reference. So the start angle is the one with a lighter green, while the end angle is the one with dark green. And when you want to render it, you need to just call the arc function and say which is the start and which is the end. How this is used within the object, we have a dedicated object once again, so a dedicated QML file that describe the properties of this object, and uses the object canvas and call the arc function, providing the parameters that we said. Once again, the progress circle is referenced within the code as an object that is part of our library. And this allows us to draw this varying speed. Just to complete the GUI, you are supposed to add similar stuff for the brindle, the oil and fuel bars, and the icons. We don't have the full time to describe deeply this part, so I'm just proposing you to look in the code and take a survey of the code where you can see it and eventually change it. Basically, you can import in Qt Creator and run it. Please remind that this is only the graphical part, because for time constraint, we're not able to provide you also the C++ interface. For the other, that will be part of the next webinar. This mainly covered the graphical part. So I would open the discussion for the question if you like. Okay, we have a question about how to tie the code to an application. We will discuss this in the next webinar, but basically what's going on is that we need to link the signals that are provided by all of these objects to something that reacts to the other events and whatever. Is QT-QML enabled in all of the IMX8 family? Let's say that from a VSP perspective, NXP do provide the integration through the Wayland backend only. So from a developer's perspective, this means nothing specific, because the developer is not dealing with Wayland. It's just dealing with the graphical aspects. And for all of the SOM, we do provide a DSP that can also build Qt. And you can see in our wiki pages the current availability about Qt version, but basically we are going to provide for all of the SOM, you have to downfile, and you can check the related Qt capability. So yes, you can use Qt with all of them. Will the C++ part cover Qt6 or Qt 5.15? Let's say that we will cover Qt 5. The main object on our side is to let you understand how to use it. We are not aiming to push you for a specific version. And we just want you to understand the philosophy beyond this, because it's a very powerful instrument that you can reuse in various environments. And the main object is just understanding the use. From one version to the other, I mean of Qt, there are changes that allow you to introduce a new feature, but it's up to you to choose one or the other. Let's say that nowadays you can start using what we provide from downfile. If I'm not sure, but should be 5.14. And for the next releases, we will go according to community. So we will provide whatever the community will decide to provide. About licenses, a good question. Let's say that at least till 5.14, there was an open source license that was requiring you to satisfy the LGPL-v3. I'm not a lawyer, so it's not that easy for me to explain all of the details, but basically, the simplest way to explain this is, as long as you share everything, you can use it. But in several aspects of the developments, you can not always share your application details. So you should contact the Qt team to understand better which is the best way for you to proceed. We're trying to understand what is changing nowadays, because as far as I can read from latest Qt 5.15 releases, there is no longer an open source release. We are trying to understand what is, but once again, if you really want to start, I would suggest to contact Qt for details. We are not Qt reseller, we are just exposing you the Qt capability, okay? I have a question about automotive. Also for this, as far as I remember, Qt provides dedicated feature for automotive, but not under the open source license. So you can contact Qt for further details. 3D acceleration. QML do provide 3D acceleration as long as the system on chip provide 3D acceleration. What I mean, as I've shown in the beginning, we have for the Varsom family, we have several SOMs. But one of these, the Varsom 6UL, has no GPU. You can still use QML on the Varsom 6UL, but you are supposed to have a software emulation of the 2D acceleration. So you can see the application running almost the same than on Varsom MX8 or Varsom MX6, but actually the CPU will be much more loaded. Someone is asking for Qt alternative. Let's say that nowadays, complete as Qt, there's merely nothing, because Qt is not just graphical. If you look at the details in the Qt description, in the Qt website, you will find tons of libraries that are not just graphics. You will find libraries managing the network, the inter-process communication, the serial buses, whatever. So from an overall perspective, as complete as Qt, there's merely nothing. If we are just talking and only talking about the graphical aspects, you may consider something like GTK3 for nowadays system. In the past, there was also GTK2, but is merely no longer used at all. And another framework that had a big use in the past, but nowadays is no longer that much, is SDL. It was mainly used for gaming, but has a very nice capability for graphic rendering. Let's say that if we are approaching a very powerful graphic processor like the Wall MX6 and the MX8 family, you can probably consider GTK3 with the Wayland backend, because it's the only one available from NXP. But if you're not targeting a powerful CPU, and let's talk about the 6UL, you can also consider light version of graphical environments like SDL, but there are also very light dedicated GUI libraries that just rely on the frame buffer and are very smart and very light, but you cannot expect the same capability that you can get with Qt. Okay, any other question? Do I need graphical interface or just frame buffer? Due to a change in the latest version of the kernel for the MX8 family only, you cannot access directly the frame buffer and get the acceleration. So you need to be careful. There are some tricks that you can find in NXP documentation that allows you to use the so-called EGLFS plugin of Qt 5, and should allow you to avoid using Wayland. But once again, we are not the kernel implementation for MX8 does not rely on the frame buffer, but on the kernel module that utilize the DRM approach. I don't want to enter in the technical detail, but basically, just be careful. You can find documentation from NXP that just tell you disable the Western Wayland framework and load the Qt using this plugin, and you can do it. But the main approach is using Wayland. For the MX6, this is less complicated, let's say, because we do have the frame buffer driver and is accelerated. And the same is valid for the 6UL. So you can directly access the frame buffer for the 6UL without an acceleration. Multi-screen support. This is something that Qt team is working on. There are some preliminary indication in the Qt forum. It's not something that easy, let's say, but you can find some details on Qt side. Let's say that from a Variscite perspective, we just propose you the environment as it is. So the current little limitation that may be present are not Variscite specific, are mainly Qt specific, because we do implement the whole framework for Qt, and we expose the whole Qt capabilities. Okay, I suppose I used all of my time, so I really thank you, all of you. Let me just remind that you can find us on our website. You can contact through the sales. Here you can find the link to our wiki, GitHub, and the customer portal. Thanks for joining and for listening to me. Bye, everybody.